Daily and monthly demand aggregations in supply chain analytics. You will learn to analyze retail demand using real-world datasets. Demand aggregation helps supply chains optimize inventory and operations. By the end, you can compute and visualize daily and monthly demand for real sales data. You will practice techniques used for forecasting, capacity planning, and supply chain monitoring. Daily and monthly insights allow better management of inventory and smoother operations. Let us dive in and solve a real operational analytics challenge. Running the cell now. We import pandas for table data manipulation. We import NumPy for numeric operations. We import matplotlib for plotting demand trends. We import warnings to keep the notebook output clean. We suppress warnings to focus on operational analytics. Running the cell now. Make sure matplotlib is working. If you do not see plots later, check your environment. What is demand data and why is it important? Demand data shows which products are bought, when, and by whom. It drives procurement, inventory, production planning, and sales forecasting. In retail, each sales transaction becomes a demand signal. Datasets usually have date, product ID, quantity, and sometimes store or customer columns. Beginners often miss issues like non-uniform time intervals or missing demand days. Analyzing aggregate demand helps supply chains avoid stockouts and excess inventory. Running the cell now. We are about to load a real retail transactions dataset to see real operational demand. We load a retail demand dataset directly from the UCI machine learning repository. We provide the URL to the Excel file and select the relevant sheet. We read the sales transactions data into a pandas data frame. We convert the invoice date column so that we can work with time-based demand. We print the number of rows and columns to check dataset size. We print the first few transactions to preview what demand data looks like. Running the cell now. This dataset contains over 540,000 retail transactions with 8 columns including date, product, quantity, price, and customer ID, showing rich demand signals for analysis. Notice how each row records a specific product sale with its timestamp and customer, illustrating how demand data captures who bought what and when. This foundational snapshot helps us understand the granularity and structure of demand data critical for forecasting and planning. Do you see the date column and quantities? Which field looks most useful to predict daily retail demand? We check for missing values in the time, quantity, and product columns. This is important because missing or bad demand data can lead to incorrect aggregations. Running the cell now. This output shows there are no missing values in the critical columns, invoice date, quantity, and stock code. This is important because complete demand data ensures accurate analysis of what products were sold, when, and in what quantity. By confirming data integrity here, we can confidently proceed with demand forecasting and inventory planning. When you find missing values, always check for a pattern. Is it just in one product, or all over the data? Many global datasets contain multiple markets or countries. We focus on one country to make demand analysis simpler. Filtering to the United Kingdom allows us to avoid double counting across regions. We print the shape to confirm how many records are specific to this country. Running the cell now. This output shows the filtered dataset for the United Kingdom contains 495,478 rows and 8 columns. Notice the large volume of records, reflecting many individual sales transactions that act as demand signals specific to one country. This filtering step focuses our analysis, ensuring demand insights are consistent and relevant to the UK market. Try using other countries and see if demand profiles change. We extract just the date part from invoice date. It is necessary to drop the time so that we can aggregate all transactions per day together. We print the transformation to make sure it worked. Running the cell now. Here, the output shows how we extract just the date from a full timestamp to create a new column, invoice day. Notice that while invoice date includes time, invoice day simplifies it to the day level, which is crucial for aggregating demand data daily, helping us analyze product sales trends by date without time detail clutter. Always check the format after creating a new time column for grouping. Now we will compute total demand for each day. We group by invoice day and sum the quantity. This gives aggregate daily demand, showing the volume of all products sold each day. We print the first 5 days and their total quantity. Running the cell now. This output shows the total quantity of products sold each day, aggregated across all products. Notice the invoice day dates and their corresponding total quantity sold, highlighting daily fluctuations in demand. This summary helps us understand overall demand trends, which are crucial for planning inventory and sales strategies. What day had the lowest or highest demand in your preview? We set up a line plot to show how daily demand changes over time. We use the dates as our x-axis. We plot the total demand on the y-axis. We add a title so our partners know the chart purpose. We label the x-axis. We label the y-axis. We adjust the chart to fit the layout. Finally, we display the daily demand trend. Running the cell now. This line plot visualizes the total quantity sold each day, showing the overall daily demand trend for the retailer. Notice the peaks and valleys, which may correspond to seasonal effects or promotions. This helps us understand demand patterns over time, a key insight for planning inventory and forecasting sales. Do you notice any demand spikes or periods of low activity? This is where operational action is needed. Let us get a business summary that managers usually want, the typical daily demand. We calculate the mean quantity sold across all days. This metric helps set expected sales for ordering and capacity planning. We print the average as whole units. Running the cell now. This output shows the average number of units sold per day, calculated from the daily demand data. Notice the value, around 13,980 units, which gives a sense of typical daily sales volume. Understanding this average demand is crucial for planning inventory and production to meet customer needs without overstocking. Is your company ordering below or above average? Compare this to current inventory levels. We move from sum across all products to a product-level aggregation. We group by both invoice day and stock code. Now we measure how much of each product is sold each day. We print the top few rows. Running the cell now. Here we see demand data aggregated by both date and product, showing the total quantity sold for each item on a specific day. Notice how multiple products and their sales counts are listed for December 1, 2010, illustrating how daily demand signals are captured at the product level. This aggregation is key for understanding sales patterns over time and helps inform inventory and procurement decisions. What product had the highest single-day sales? Try sorting by quantity to find out. To help operations prioritize, let us find the most in-demand products. We group all data by stock code and sum the quantity sold. We sort the products from highest to lowest demand. We print the top 5 products which drive most of the demand. Running the cell now. This output shows the top 5 best-selling products in the dataset, identified by their stock code, along with the total quantity sold for each. Notice how the code aggregates demand data by product, highlighting which items are in highest demand overall. This helps businesses prioritize inventory and procurement by focusing on their most popular products. Should your company focus forecasting and inventory on these top products? Usually, yes. We extract the month from the invoice date for monthly analysis. We sum demand by month, giving a bigger picture for planning. We make a new bar chart for monthly demand. We adjust the figure size for readability. We plot demand as a bar chart with each month as a category. We set the title for monthly context. We label the x-axis as months. We label the y-axis as quantity sold. We rotate labels for visibility. We finalize the plot to show periodic demand surges or drops. Running the cell now. This bar chart displays the total quantity of products sold each month, aggregating daily sales into clear monthly demand trends. Notice the shape of the bars reveals peak and low demand periods, which helps in understanding seasonal patterns and planning inventory accordingly. This visualization demonstrates how summarizing demand data by time enables better decision-making in retail operations. Are there any seasonality patterns? This helps you plan for busy and slow periods. Many companies neglect quiet days, so let us see if our data has any days without sales. We create a date range covering the whole dataset period. We create a set of days that do have transactional demand. We create a list of days that are missing from the dataset. We print how many no-demand days exist. We print the first few such days to investigate further. Running the cell now. This output reveals there are 69 days with no recorded demand, indicating 0 sales or missing data days within the observed period. Noticing these missing demand days is crucial because uninterrupted demand data supports accurate inventory and sales forecasting, highlighting the need to handle or adjust for these gaps when analyzing historical sales patterns. If missing days mean a store was closed, demand is truly 0. If due to bad data, address it. Understanding the type of invoice helps spot operational differences between credit and normal sales. We conditionally check for the invoice no column for our split. We categorize invoices by whether they are credits, usually returns, or normal sales. We summarize demand split by type for operations. We print the total demand by each invoice type. Running the cell now. If credit returns are high, there could be a quality or service problem. Managers often want to see time trends for the best sellers side by side. We select the top 3 most demanded products. We filter the daily demand to these 3 products. We create a pivot table with dates as rows and products as columns. We replace missing values with 0 and print results. This helps compare demand patterns. Running the cell now. This pivot table summarizes daily demand for the top 3 products by showing their quantities sold each day, with dates as rows and product codes as columns. Notice how demand varies day to day and differs across products, highlighting patterns essential for planning inventory and procurement. This format makes it easier to analyze and forecast product-specific demand trends over time. Try plotting this pivot table. Does any product have a spiky demand? Operational analytics uses rolling averages to smooth out daily noise and spot trends. We take our pivot table and apply a 7-day rolling mean window. This computes the average sold per product for the current day and previous 6 days. We print part of the result. This is used in supply chain to set order points and spot trends. Running the cell now. This output shows the 7-day rolling average demand for 3 products over time, smoothing daily fluctuations to reveal clearer trends. Notice how the averages start high and then generally decrease or stabilize, reflecting changing customer demand patterns. This helps in understanding demand dynamics and supports better inventory and production planning decisions. Does a rolling average reveal seasonal or promotional effects you did not notice before? You want to know if operations are busier on Mondays or Fridays. Let us see the demand split by weekday. We create a new column holding the weekday name. We sum the quantity sold for each weekday. We order weekdays from Monday to Sunday for clear reporting. We print the results. This tells you when to schedule more staff or receive deliveries. Running the cell now. This output shows the total quantity of products sold on each weekday, revealing clear demand patterns throughout the week. Notice the peak on Thursday and the missing data for Saturday, which highlights operational insights like when demand spikes or gaps occur. Aggregating demand by weekday helps businesses plan inventory and staffing around these predictable sales trends. Does your demand spike on weekends or weekdays? Plan staff and orders accordingly. Missing days break time series analysis. Let us see how to handle and fill them. We use a try-except block to catch errors. We re-index to a full date range, inserting 0 demand on missing days. We print the result. This smooths out downstream analysis. If an error occurs, we print the error for troubleshooting. Running the cell now. This output shows daily demand quantities indexed by date, with a key detail: the missing date of December 4th is filled with 0 sales rather than being dropped. Notice the 0 value, which ensures a continuous time series without gaps, crucial for accurate analysis and forecasting in demand data. This demonstrates how handling missing dates preserves the integrity of your demand dataset for reliable planning. Practice making your aggregation robust to missing days. It is essential for reliable KPIs. Watch how to handle time series gaps on YouTube for more troubleshooting tips. Negative demand can appear due to returns or errors. We filter for sales transactions with negative return quantities. We count how many such rows exist. We print a few example records to check. You may need to handle or separate returns in real forecasts. Running the cell now. This output reveals that there are 9,192 rows with negative quantities, indicating product returns or cancelled sales. Noticing the negative values in the quantity column is crucial because demand data must account for both purchases and returns to accurately reflect true customer demand. This step ensures the dataset is cleaned and interpreted correctly for reliable forecasting and planning. Should you exclude returns or keep them in for true demand planning? Discuss with your business partners. Sometimes operations analysts join 2 time series incorrectly. We aggregate 2 ways, by sum and by mean, both by date. We compare the indexes, dates, side by side. If they do not match, we alert the user. If they do match, we confirm safe usage. Catching these mismatches saves hours of debugging. Running the cell now. This output confirms that the dates used in both the sum and mean aggregations line up perfectly, meaning our demand data is consistently recorded for every day. This alignment is crucial because mismatched dates would indicate missing or irregular sales records, which could distort procurement and forecasting decisions. Ensuring aggregation dates match helps maintain data integrity when analyzing daily product demand. Always check date alignment before combining KPIs from multiple aggregations. Best practices for demand aggregation. Always check for missing, duplicated, and 0 demand days. Use explicit time periods, day, week, month, for all KPIs. Separate product level and company level aggregations. Rolling averages help smooth operational noise. Pivot tables make comparison across products easier. Visualize trends before reporting to your team. Never join datasets without verifying matching time indices. Running the cell now. Let us create several time-based aggregations at once to compare KPIs. We create a new data frame with date and quantity. We add columns for daily, weekly, and monthly periods. We extract the week as the start of each week. We extract the month as the first of each month. We aggregate and rename the daily quantity column. We aggregate and rename the weekly quantity column. We aggregate and rename the monthly quantity column. We print the start of the monthly aggregated demand, perfect for reporting. Running the cell now. This output shows the total demand aggregated by month, with key monthly quantities decreasing from December 2010 through February 2011 before rising again. It demonstrates the importance of using explicit time periods, in this case, monthly, to effectively track and compare demand trends over time as part of best practices in demand aggregation. KPIs at multiple time scales let you align procurement, replenishment, and sales cycles. End-to-end example, from raw transactions to actionable insights. You will walk through loading, cleaning, aggregating, and plotting real retail demand data. You will find operational surges and slowdowns. You will finish with a suggestion that can impact inventory or promotion strategy. Running the cell now. Let us automate our best practices and work like a supply chain analyst. We reload the data for clean analysis. We filter to United Kingdom for operational focus. We convert invoice date to date time for time series. We remove negative, return, quantities for baseline demand. We extract the invoice day. We print how many transaction rows remain, a healthy baseline. Running the cell now. This output shows the number of rows remaining after filtering the raw dataset to include only positive sales transactions from the UK, ensuring clean and relevant data for analysis. Noticing this count confirms that the data cleaning step was successful, providing a solid foundation for identifying trends and operational patterns in later sections. This step is essential for producing reliable insights that can guide inventory or promotion strategies. Always start your pipeline with data cleaning. Errors here will affect all downstream analytics. We re-aggregate clean data to monthly totals. We use a bar plot for clear volume presentation. We add a title specific to our clean data. We label the y-axis. We label the x-axis. We make sure the layout does not cut off labels. We show the final monthly trend so managers can take action. Running the cell now. Here we see a bar chart showing total units sold each month after cleaning the data, highlighting clear fluctuations in demand over time. Notice the peaks and troughs, which indicate operational surges and slowdowns critical for adjusting inventory and promotional efforts. This aggregation and visualization step helps transform raw transactional data into actionable monthly insights. What month is best for launching promotions or ordering extra inventory? Subscribe to the YouTube channel for more demand aggregation analytics.